Good day, everyone. We are Group 4 and we will be presenting the water and its properties. One of the most vital elements on Earth is water, due to its polarity and capacity to create hydrogen bonds, which enables it to dissolve a variety of compounds. It is also a superb solvent. Since it is non-toxic, non-flammable, and has a large heat capacity for absorbing the energy produced during a chemical reaction, is reasonably priced, and is generally available. Water is essentially the natural medium for all biochemical reactions. Water may form hydrogen bonds with other polar molecules and ions because of its polarity, which makes it possible for them to dissolve in it. The system's overall temperature can remain constant despite the addition of extra energy because the hydrogen bonds between water continuously break and reform as a temperature rises. This experiment aims to understand the uses of water as a solvent and as a medium for biochemical reactions, describe some of properties of water and relate them to hydrogen bonding, and lastly, discover the unique properties of water.
For the methodology, the first part of the procedure, entitled Water as a Universal Solvent, was conducted by adding zero point 0.5 grams of substance such as NaCl, sugar, gelatin, margarine, and ethanol into separate test tubes to test water as a universal solvent. Then 1 ml of water was added to each test tube and was stirred vigorously in order to dissolve the substance. For those substances that did not dissolve, another ml of water was added and stirred again. This process was repeated 3 times to ensure that the other substances would dissolve as well. After the whole process of testing the water as a universal solvent, the procedure was then repeated, but instead of water, acetone was used. The next part of the procedure, wherein it aims to prove that water is a good medium for biochemical reactions, about 1 gram of citric acid powder and sodium bicarbonate was mixed. Then about 10 ml of water is added to the mixture, which shows the occurrence of the chemical reaction. As for the observation, it was noted that the mixture forms bubbles and the temperature was cold. Going on to the result and discussion, here we can see the table containing the solubility of each substance in water and in acetone. First, we have the NaCl, or sodium chloride, in water and acetone. It is soluble in water and partially soluble in acetone. The reason behind this was because that the covalent bonds of water were stronger than the ionic bonds in the salt molecules. To further explain, salt dissolves in water due to the fact that both water and compounds are polar, having positive and negative charges on opposite sides of the molecule. Although both water and acetone were polar, the solubility of salt to acetone was partial. This is because acetone is an organic compound or solvent, and organic molecules have limited solubility or are completely insoluble compared to water. Acetone is incapable of breaking the strong bonds of NaCl. Second, we have sugar in water and acetone. It is soluble in water and partially soluble in acetone. The normal table sugar is made up of sucrose. Sucrose is made of a glucose molecule bonded to a fructose molecule. The oxygen hydrogen bonds of sucrose results to polar areas, and these polar areas fold one sucrose molecule to another to make up a solid sugar. The polar ends of water molecules attract the opposite polar areas of the sucrose molecules and separate one sucrose molecule from another. This makes the sucrose dissolve in water. On the other hand, what happens in the conducted experiment, sugar did not dissolve in acetone, but according to some studies, sugar is soluble to acetone since both sugar and acetone are nonpolar. Third, the solubility of gelatin to water and acetone. It appears that gelatin is only soluble in water and not in acetone. This is because gelatin consists of shorter strands with fewer chemical bonds between them. These smaller fragments in gelatin make the gelatin dissolve in water. On the other hand, it is insoluble in acetone since it is less polar and is an organic solvent. Fourth, margarine and its solubility to water and acetone. In both solvents, margarine was insoluble. The reason was simply because margarine is fat soluble and does not have any polar parts. For them to dissolve in water, they would have to break some of the hydrogen bonds. Margarine is acetone insoluble since it contains triglycerides. However, in some studies, it was stated that lipids are highly soluble in the nonpolar or weakly polar organic solvents, including ether, chloroform, benzene, and acetone. In addition, acetone is very potent and can dissolve both organic and inorganic substance. Due to its ability to quickly dissolve and evaporate, acetone is utilized as a polar and a protic solvent. Its its volatility, the glassware or the test tube was easily cleaned, causing the margarine to clump together, then dissolve in the acetone. Lastly, the solubility of ethanol to water and acetone. Excuse me. Ethanol appears to be soluble or miscible in both water and acetone since ethanol is an organic liquid that is polar and has smaller molecules. Excuse me. Due to this, it makes ethanol soluble in water. It is also because of its hydroxyl group that we're able to form hydrogen bonds with the water molecules that makes ethanol soluble or miscible. On the other hand, ethanol is soluble or miscible in acetone as well. However, what makes it different from being soluble in water is that acetone is less likely to form hydrogen bonds. The oxygen in the alcohol goes after carbon on the carbonyl group. Next slide, please. As for the reaction of citric acid and sodium bicarbonate, when powdered citric acid and sodium bicarbonate are mixed, no chemical reaction occurs. However, when water is added to the mixture, it begins to have a reaction and bubbles are formed. Compared to the other reaction, wherein lemon extract is used as a substitute for citric acid and eventually mixed with sodium bicarbonate that acts as a weak base, begins to react with the lemon extract, resulting in a fizz or foam that starts to move upward. Subsequently, water is added, resulting in prevention of overflowing of the foam from the tube.
For the conclusion and recommendation, water is known as the universal solvent because of its enormous capacity to disintegrate a wide range of molecules. It is the capacity that makes water such a crucial life-sustaining factor. Water's function as a solvent acid cells in the transfer and utilization of chemicals like oxygen and nutrients on a biological level. Blood and other water-based fluids assist in transporting molecules to the required regions. As a result, water's function as a solvent makes it easier for molecules like oxygen to go through the body during respiration and has a significant impact on how quickly medications can reach their intended targets in the body. After doing this study, After doing and studying this experiment, we discovered the unique properties of water, which are: water is polar, an excellent solvent, has a high heat capacity, has high heat of vaporization, has cohesive and adhesive properties, less dense as a solid than as a liquid. The molecular makeup of water holds the key to understanding its chemical behavior. A water molecule has a bent overall structure and is made up of two oxygen atoms bound to an oxygen atom. This is because the oxygen atom additionally carries two pairs of unshared electrons in addition to making bonds with the hydrogen atoms. Shared and unshared electrons pairs repel one another. Water molecules joyfully attract one another due to their polarity. A hydrogen atom's plus n joins forces with an oxygen atom's negative n. Citric acid and the substitute demonstrate that the outcome is identical, but the speed of reaction demonstrates that citric acid is more potent than the substitute. Using dry powdered citric acid as opposed to substitutes like lemon and calamansi makes the outcome more obvious. Citric acid is more powerful and effective than the alternatives. That's all for today. Thank you for listening.